I mean the QR code for registration of your attendance on the screen. I will put the link in the chat as well in case you don't have your camera. Please register your attendance. And I will bring up my PG admin. Switch everything, maybe space everything. How is it going, everyone? What happened, guys? You sad? You upset? No one says anything.
Sorry, I just back from the toilet. What you ask right just now?
I just asked why everyone is so quiet. You guys, you okay? Are you upset?
At least I'm fine with it.
That's good to hear. Okay, you mean. So I hope everyone is okay. It's Friday, guys. Be happy. You will finish this one in an hour and you can enjoy your weekend. Okay, so today, one more time, I just display the QR code in case you need it. Please register your attendance, everyone. I put the link in the chat as well, so feel free to log in and register your attendance. For the first part of the worksheet today, we are going to practice three-level logic in SQL. You understand in most of the programming languages that you are familiar with, we have two-level language, which means if you investigate a particular statement, so sorry, you either get a true or false, right? But for SQL, it's different. You have three-level logic, which means when you evaluate a statement, it might be true, false, or unknown. And that's because of null values. So you have to be careful about your null values. So here, to practice this three-level logics, you are given a sample relation. You just copy paste this one into your PG admin, and you can simply see what is in there. I just run it, and now you can see this is your R relation, right? You have tuples A and B. In column A, you have some values, some null values, and in column B, again, you have a mixture of null and like integer values. So what will happen if you write a query that returns those tuples that have A is equal to 10? If I simply do this for 1A, if I do select star where A is equal to 10, what do you expect to see? I will get all tuples that have A is equal to 10, not null, because null is not 10, and B can be anything, including null. So if I run this query, you will get all the tuples that have A is equal to 10, and B can be anything, including null. Does that make sense, everyone?
Yes.
That's good. Now, what will happen if you write a query to return all tuples that have A is equal to 10 or B is equal to 20? So you have to write something like this: B select star where A is equal to 10 or or B is equal to 20. It's not case sensitive, but by the way, I prefer to just change it to B, lowercase b. And now if I run this, I will get, remember, my R tuple was like that, right? If I just run it again, this is my R relation. So I will get all the tuples that have A is equal to 10, these two, or B is equal to 20, right? So A is 10, B can be 20, B can be null. So you will get both this. And from the second part, because you have an OR operator, you will get B is equal to 20, this one or this one. A can be null. So you will get these three tuples if I run this query. Does that make sense? You have A can be 10 from the first part. B can be anything, so you have either 20 or null. Null is also included in the output. And for the second part, you will get B is equal to 20, so you have these two, where you can see even A is equal to null has been, it's better not to say A is equal to null. The null values for A is actually included as well. Does that make sense, everyone? If not, just tell me, I'm happy to explain it. All good? Now, what will happen if you do part C? And select start R, where A is equal to 10 and B is equal to 20. What do you expect to see here? This time, you get only those tuples that have A exactly equal to 10, not null, B equal to 20, not null, because you understand null is not 10, null is not 20. So the only tuple that will appear in this, for this query would be this one. If I run it, you will see the output is just one single tuple, 10 and 20. Everything is clear, guys? Makes sense? Now, what if you do or where, where A is less than 10 and not is equal to 20. Look at your R relation one more time. This is your R. You are saying that I want to get all tuples that have A is less than 10 and not null. You understand? You cannot have null because when you compare null with 10, null is less than 10, they return unknown. So it won't be true. You won't get it in this particular query. So you will get all tuples that have A is less than 10 and not null. So you will get these two tuples. And B has to be not equal to 20 and not null. So you will get either, again, these two. It cannot be null. You understand that from all these tuples, the only that satisfies both conditions would be this one. So if I run the query, the tuple that I will get is the one. Does that make sense? Is that clear, guys? I hope so. Guys, are you happy with the pace? Would you like me to slow down a bit? You good? Okay. Now for the next couple of questions, you have to use the link that is provided, the university schema. You can see it on the like on the W5. If you just click on this university schema SQL, I have it open here. You can copy paste everything and it will create some tables and populate data into the tables for you. So I just copy paste it. Control C, Control V, up to here. Run, and I refresh my tables. You see, it creates all these tables for me. And just for your eyes, I tried to create a kind of physical design model. You can see all the tables that exist in this table. I'll give you some time to go through the code and find the relationship that exists between different tables in this schema. So you see we have transcript table, we have lecture table, it's here. We have unit of offering, we have requires, it's here. We have classroom, we have when offered, we have student, academic staff, and unit of study. We have all these tables. There are actually how many? 9 tables. Of course, not a problem. Let me just quickly show it to you. You happy? And if you want, I can put the link in the chat as well, just in case. Let me just put it in the chat. Good, no worries. So if you just go through the tables, you see the constraint that we have for each of these tables. We have a student table, student ID is the primary key, academic staff ID is the primary key of the table, unit of study, again, we have a unit of study like here, sorry, this one. The primary key is unit of study code. Then we have some relationships. If you look at the required table, for example, we have consider foreign key from our unit of study table. Most unit of study code and prerequisite unit of study code are foreign keys from our unit of study table. And you just go through it, you find all the connections. I just visualize it try to use an illustration to make it kind of visually clear to you guys. So it's all there. Now, using this schema, we are going to actually write some queries. For the first part, it says you have the like questions in front of you. I prefer to keep that up just for your eyes. You can read the questions from the worksheet in front of you. I keep this one. Everyone can read it like from the worksheet, and we will try it together. For the first part, it says you have to write a SQL query that answers this question, and you have to use a set operator. Be careful in your assessments. You have to read the question like completely. You have to make sure that if it dictates you to use a particular method, here it says you have to use set operator. When it says you have to use a subquery, you have to stick to the like method that the question asks you. Otherwise, you will lose mark. So it says which lecturers by ID and name. So you understand that the ID and name of our lecturers is in our academic staff table, right? We want to see which one of these academic staffs have taught a particular unit, actually 2 units, Info 2120 and Info 3404. So you understand, we don't have anything regarding the unit of study code in our academic staff table. If you want to filter the academic staff, the ID and name of them, based on the unit of study that they have taught, we have to join the 2 tables, right? But here it says you have to actually use set operators. So how we can do this? This is part 2A. I want to get the ID and name of the academic staff. So select ID, name, you understand that because I want to shortlist them based on the units of study that they have taught, I need to join the 2 tables, right? So I put
Excuse me, ma'am.
Yes.
Sorry, I tried to copy paste this code in my PG admin. When I tried to paste, it came in one line, not like this.
That's all right. You understand everything that ends with a kind of semicolon is one single command. It doesn't matter if you just merge everything in one single line, but we prefer to split it into multiple lines for our eyes, for like readability and as a kind of, good practice in coding.
Oh,
but
okay.
It doesn't mean that when you execute it, it results in a separate or in a different result.
Okay.
You can check under the tables. You have all the tables listed, and that's totally fine. Don't worry about that. Now, what I was talking about, yeah, we need to join the 2 tables because we want to apply a condition that is actually unit of study code that applies to the unit of study codes, and unit of study code sits in your unit of study offering. So we need to join the 2 tables. So we have unit of study offering. What is the common column between the 2 tables? The next one would be on. You understand ID of academic staff has to be matched with the structure ID of your unit of study offering. So you put ID is equal to instructor ID. Right? Everything is clear so far? You understand why we need to join the 2 tables? And this is the equi-join. You have to include it. Now, you have to apply the condition. And you have to make sure that you are using set operators. I can treat this question. I can split it into 2 sets. I want to create a set of academic staff who have taught the first unit, Info 2120, and the second set would be those staff who have taught the second unit, Info 3404. So I just create the first set by using this condition where unit of study code is equal to Info, what was that? 2120. Am I right? This is the first set. And I have another query to produce the second set for those academic staff who have taught the other unit. So I have something very similar to this query. And this one would be for 3404. What's the operator that I have to apply, that I have to use between the 2 sets? Read the question again. Which lecturers by ID and name have taught both 2120 and 3404? What's the operator, the set operator that I have to put in between? Oh my God. See, we have, let me just start with the concept of, yes, Marco, you are right. So it has to be intersect. But before we just move forward, regarding the question that you have asked in the chat, see, you understand why we have to use two tables. Yuming, tell me if it's not clear why we have to use the two tables. Is that clear why we have to? So you understand, because we want to get the name and ID of the staffs, but this has to be filtered based on the unit of study, you have to join the two tables, right? So there are different ways to join two tables. One way is to put from academic staff, comma, instead of join, you can simply put comma, then the name of the second table, which is unit of study offering, and then here you can use a where clause. And the where clause has to be exactly the same as what you have here. You have to match ID from your staff, academic staff, to instructor ID from your unit of study offering. But if you use join, which is preferred, I would say if you are working with a kind of data set that has thousands of records, if you use join, it would overperform, like it would perform faster compared with where clause, then you just use comma within the two tables, right? So when you use join, then you have to use on to provide the equation, what was that, equi-join condition. You mean, did you get your answer? So when you use join, right after it, you have to use on. It's kind of the way that you can, if you want to use explicit join to join the two tables, because we have different methods, then you have to provide on. If you miss this one, then rather than joining the two tables, getting the inner join of the two tables, you will get the actually cross product of the two tables. If we don't use on, ID and instructor would be two attributes. If you don't include this line, if I comment it out, rather than getting the inner join of the two tables, you understand that we are working actually with two sets, right? Oh my God, my drawing is just embarrassing me. So we have two sets here. This is set A. Let's say this is A, this is B, right? When you use join, you actually get the intersection of the two, right? Don't miss it with this one and mix it with this one. It's just something different. When you join the two tables, we have inner join, we have outer join, and we have, if you don't provide the condition, you will get the cross join, which means that for every tuple that you have here, you will get the corresponding here. So if you have this one, for every single circle that you have here, you will get the corresponding cross, in the case that you don't provide this one. Does that make sense? Okay, that's good. No worries. So what we were after, yes, Marco, thank you for the answer. You understand that here, because we want to have both conditions, you have to use intersect, right? This is the set operator that you have to use if you want to get those academic staff who have taught this one and this one. So if you run the query, you will get this guy. This guy has taught both Info 2120 and Info 3404, right? And actually, you can do it like in section B, it asks you to do the same thing without using a set operator. This time, rather than using a set operator, this intersect, you have to use a subquery. How we can do that? It's simple. What you have to do in section 2B, what you are going to do, you want to get exactly the same result, but here you are not allowed to use intersect. You have to use a subquery. What we have to do, we want to get the ID of those instructor, because you know that we have to work with ID. ID is the common color between unit of study offering and academic staff. we get the ID, instructor ID of those instructor who have taught those particular units, and then we look up for the name, right? We can do that. So what we have to do here, you can say select ID and name. This part is exactly the same. You still need to join the two tables. You understand why? Because we are working with columns that are sitting in two different tables. So it's just so annoying. But here, when you apply the first condition, where unit of study code equal to info, let's say 2120. Now, what you can do, you can actually write a subquery to return the ID of the instructor who have taught the other units. So you can say and ID, then you can write a subquery. I just use indentation to make the subquery distinct. Select instructor ID from which table? From your unit of study offering, right? From unit of study offering, where unit of study code is equal to the other unit, info 3404. If I run this query, you will get the same result unless you have some duplicates. To get rid of duplicates, you can simply add distinct here, right? Distinct. And you see, you can get exactly the same person. Remember, we can actually do it in another way. Again, rather than like doing the join, you can use a subquery. So another way for doing the same thing would be like this. What you can do, you can get the ID and name from your academic staff. Rather than doing this, you put where, and then you look up the ID in your unit of study. Let me just get rid of everything here. This one has to be where ID in instructor ID from unit of study offering, where unit of study code in this range. It has to be either this one or the other that you have, info 2120, come on, and then this guy has to go at the end. There we go, right? And you will get exactly the same result. Look, there we go. All good, everyone? Hello, you're still there. Okay. So now for section C, you have to write a SQL query to give the student ID. So see, when you read the question, you look at like the tables, what you are going to get, what you are going to query. This is just the student IDs of all the students who have enrolled in only one lecture. So you understand, you have a student ID in your student table and in your transcript table because you want to filter them based on the unit that they are like enrolled in. You have to work with your transcript table, right? You don't really need your student table because you just want to query student IDs. If it was names, you have to join it with your student table. But here, because you just want to get the student IDs, you can work with your transcript table. That's all. So what we have here, this is section 2C. So it says, select. I want to get the student IDs. Select. Look at this. Select student ID from transcript. Where, it's not where, right? You understand. I want to look at the total number of units that each student is enrolled in. So I have to look, actually use an aggregate function. I have to count the number of units that each student is enrolled in. So you remember, when we want to use an aggregate function, if I want to get it for every single student in my table, I have to use group by, right? So I put group by. The order matters. You have to be careful. You put group by student ID because I want to get it for every single student that I have in my table. And the condition is group by needs a space here. The condition is actually having, because it's an aggregate function, you have to use having. Remember that. Having count, you can simply put star, which means that that student is enrolled in one single unit. And it asks you to order the output. So order by is the last one. So remember this order. Select from. If you have very close, it has to be after from. Then you have group by, then having, and then order by comes at the end. So you have order by student ID. Does that make sense, everyone? Do you understand why we have to do this? We want to get the total number of units that each student is actually enrolled in. So we have to use an aggregate function count. If you want to get it for every single student, you have to use group by. Otherwise, you will get just one single value for the whole table. You want to get it for each student, like what we have here. For student one, you have like a different value. Then you have to filter them. You just want to get those students who are enrolled in one single unit. So you will apply this condition using having. When you have a condition that applies to an aggregate function, you have to use having. And at the end, it asks you to order the output by student ID. So it's like this. Questions, guys? Does everything make sense? Would you like me to explain any part? You okay? Silence is sometimes scary. I don't know. Oh, okay. So, part D. In part D, you have to write a SQL query to give the names. It's exactly the same condition. You want to get the students assigned names that have enrolled in one single unit, right? So it's super simple. You write the query to get the student IDs. You know that the name of the student sits in your student table. The only thing that you have to do is using this query as a subquery. It returns the student ID. Then you can look up that particular student ID in your student table and find the corresponding name. So what you have to do here is as simple as this. Select name student, because you know that the name of the student sits in your student table, right? Then where the student ID comes from this, oops, look at this, comes from this subquery. Then I just use indentation to make the subquery distinct, and I just simply copy paste this one. I know the student ID of those students who are enrolled in one single unit. So all I need to do is just look up the student IDs and find the corresponding name for them, right? And it doesn't actually ask you to order. You can get rid of this one. And if I run it, this time rather than the student IDs, you will get the name of the students. Is that clear, everyone? Guys, are you happy with the pace? Would you like me to slow down a bit? Yes, sure. Would you like me to repeat any part? Part C and D, both of them are clear. Would you like me to explain any of them?
Hello.
Hello.
I just do the part C on my computer. I found if I just delete the order by student ID, I think the result is the same with the way I add just for the output.
Let me just
any difference.
What you are saying is that if you don't get rid of order by, you will get exactly the same result. Is that what you are asking?
Yeah.
Well, that doesn't matter. See, if I just, it might be the case that the data that you have in your output is actually somehow like, because you are, it's just kind of a bit, if I just comment out this bit and run it, you, let me just do it, yeah. This is what I will get without, for part C, you said, right?
Yeah.
So you see, if I don't have order by, you understand that when you don't include descending or ascending, by default, it is ascending, right? It's in ascending order. If you look at this one, is it in ascending order? Not really. It doesn't have any order, I think. It's not order.
Yeah.
Because if it was in ascending order, we expected this one to be here, and then this one has to be here. So these two have to be substituted. But when I include order by, what will happen? I will get a different result. Would you like to share your screen?
Yeah, that's actually the same. Just for result, you just say that we have to do that. I think if we just want to get the result, I think maybe order by is not necessary. I mean, have to do, you know.
You mean you are saying that if you put order by, it doesn't make any difference to when you don't have order by. Is that what you are asking, right?
Yeah. Just
would you mind if I ask you to share your screen and show me the result?
Okay. I think it's the same result with your screen, in your screen, I think.
You just share your screen. I want to just try something.
I just find that window.
Okay. So if you don't mind, I just request for remote access. I want to try something. So here you have a student ID, group by student ID, exactly, everything. And if you look at the output.
This order.
Let me just try it. This is the one that you get. And if I just simply comment out this one, why it doesn't comment it, I will do that. There you go. Okay. This time, if I just run it, I will get this one. It's different. Why you say it's the same? See, you have 305, 309, 305, 309. But if I add order by, you will get, look at this. Just look at the table. See how the result differ. 305, 305, 309, 309. You see, it's different.
Oh. And just wondering, I mean the content actually is the same. The content.
Yes, for sure. The content has to be the same, but you just change the order that you display the content.
I just wonder why you say that we have to order that. I think maybe we don't have to order
That's absolutely, yeah. The content is exactly the same, but you order it. That's what you expect from order by. It doesn't do the magic. It doesn't produce any content for you. It just order the output. Okay. So you understand, order by, it's kind of just self-explanatory. It's just order the output. You didn't expect something like producing a new content for you. It's just like order the result for you.
Okay.
Would you mind if you stop sharing your screen? We can like keep the rest of the questions, doing the rest of the questions. Okay, so now what will be you can see my screen, right? We were up to section D. You understand this part. We simply get the student ID from the query that we have written before, and then by looking out the student IDs that we get from the subquery, we can find the corresponding names for section D. Now in section E, it asks you to write a SQL query to give the student IDs and names. So be careful. We want to get both the ID and names. And the condition that we have is the same as what we have in the previous section, but this time you are not allowed to use a subquery. What we have to do, you understand, you want to apply the condition on the unit of study, number of unit of study that each student is enrolled in. So you need to work with your transcript table. But because this time you are going to print the name of the students, you have to join the two tables, right? So the key is joining the two tables. You are not allowed to do use subquery. You can simply do it this way. To E, select, you want to get student ID, name. Again, it's not case sensitive, but this is a student ID. From, you have to join the two tables. You have your student table, and why not? We can just use natural join because the name of the column is student ID in both tables. So you can simply, just to make your life easier, you can use natural join, and then you don't have to worry about including the quick join condition, right? You just simply put student, natural join, transcript, and it will take care of the common column between the two. Then what we have here, the condition is the same. You have to apply group by. This time in your select, you have a student ID and name, both of them. So you have to include both. You have student ID, comma, name. Whatever you have in your select, you have to put it here. And then having, like what we have in the previous example, count star equal to 1. And it says you have to order the result by student ID. So the last line would be order by, again, space, student ID. Right? So because you are not allowed to use subquery here, we just use join. If you want, you can use natural join, you can use join. If you use join, remember that you have to include on student ID from, you have to use alias student ID from your student table is equal to a student ID from your transcript table. And now if I run it, this time you will get both the student ID and the student name. Remember that the order, select from, if you have join on, where clause, group by, having, order by. The order, you remember the order. Any questions, guys? All good? Now for question, for part F, write a SQL query to give the names of all the students who have enrolled in only one lecture without using a subquery. it's very similar to this one. This time we don't want to output the student ID, we just need the name of the students. And we are not allowed to use software. So we just use the same like method that we use here. We use national join or join, doesn't matter. So the only difference is you don't need student ID, but in your group by, you understand you still have to include the student ID because you want to get the total number of units that each student is enrolled in, based on for every single student ID that you have in your transcript table. So you put it here, even though you don't have it in your select. Does that make sense? And it doesn't ask you to order the results. You can simply comment out or get rid of this line. So you have select name from student, natural join, transcript. You know why you have to do this, because you want to get the name of the student. The name of the student sits in your student table. However, you are working with your transcript to get the total number of units that each student is enrolled in. You have to group by to get the total number of course or units that each student is enrolled in. And then to apply the condition on an aggregate function, you have to use heading, right? Now, if I run it, this time I will get the same result, but I don't have the student ID. I just have the names. These four names, Sally, Pauline, Victoria, and Sally, you will get them. Questions? Because in your transcript table, you understand if you want to get it based on different students, you have to group them by student ID. If you don't include a student ID, how you can make sure that it's like separated? It's based on the student ID, right? That you have to categorize, you have to group them by. Did you get your answer, Leah? Let me know if it doesn't make sense. See, it's not just PK. If you have other stuff in front of your select, you have to include whatever you have here, because you understand that at the end, when you want to group them by, you want to have it for every single student. How we can what's the thing that you can use to distinguish the students here? It's the student ID, right? So you don't have a student ID in your select, but you have to include it in your group by. And you can see that if you don't include it here, you will get a different result. See, the result is different. You just lose that Sally. So you have to include it. Otherwise, the transcript won't be grouped by properly. I hope it's clear. Let me know if it doesn't make sense. I will try to. Okay. Now for 2B, you have to write a SQL query to give the student IDs. It's just a student IDs this time, of all students who have enrolled in only one unit of study, and order the result by student ID. Note, a student can enroll in the same unit of study multiple times. So let's have a look at our transcript table. Let's try this one. We just put it somewhere here. This is not the answer for 2G. I just try to investigate my transcript table. Select star. If I look at my transcript table, you see I have the same student, this guy with this student ID. He has taken this unit, exactly the same unit, in 2 years, 2009, 2010. So you might have students that taking the same unit in different semesters in different years, right? But it won't be counted as like distinct units. Based on the questions, it says that this counted as one unit of a study if they have taken that unit in multiple semesters or in multiple years and several years. In different years, you have to count it as just one. What we have to do in this case, see, we want to get the student IDs. For those who are enrolled in only one unit of a study, but you have to be careful that unit of a study, even in this case, you have to count it just once. What we can do here, you can do it this way. See, I want to get the name of the students. Name of the student sits in my student table, right? And the condition applies on transcript, so you still need to join tables. G, does it says? No, you don't need to join them because it just asks you to print the student IDs, not the name, so you can work with your transcript table, right? All you need is here in your transcript table. I want to print the student ID from transcript. I have to group them by student ID, but to get unique student a unit of study code where I count the like codes, I have to make sure that they are these things. So having count here you put distinct because you don't want to count these two as two separate units, right? So you put distinct unit of study code. It has to be equal to 1. And then it says you have to order them by student ID. So the last thing would be order by student ID. Right? My comment. So the difference here is we want to get unique student codes, and you understand that if a student is enrolled in the same unit in different years or in different semesters, it will be counted just as one unit of study. So we just put distinct unit of study code here, and if you run it, you will get the unit of study student IDs for those who are enrolled in one unit of study. Even though they have like enrolled in one unit multiple times, you will have their student ID here because it won't count it as a distinct unit. Does that make sense, everyone? Questions, guys? You good? No questions? And part H, finally. What it says write a SQL query to give the student IDs and names. So we need to print both IDs and names of all the students who have enrolled in only one unit of study, and order the result by student ID. Note that a student can enroll in the same unit of study multiple times, which is still counted as one unit of study. So it's very similar to what we have done like here. The only thing is this time we want to get the name as well. It's very similar to like this part, right? We wrote the query to get the IDs. Now, if you want to get the names, you can simply use that as a subquery. It doesn't say that you cannot use a subquery, so you can simply do that. Or you can simply join the two tables. You know that if you want to get the name of the students, you have to join the student and transcript tables. You can simply do this. Select. Let me just check something. Okay. Select student ID, name from. We have to join two tables because you understand that we want to get both name. Name is not in your transcript table, it's in your student table, so you need to join a student. You can simply use natural join to make your life easier. Natural join. The other table is, or what you can do even better, because you understand that you want to get just the unique unit of study code for each student. So you can do it this way. You can simply say, I want to create that table. I put select. I just get the distinct combination of a student and unit of study codes. So you put unique. Let me just use some indentation to make the like this new table that I'm creating like this thing. I just get the distinct tuples of students and unit of study code because this is what I'm after, right? So you put distinct student ID, comma. This thing I just missed some these things. Sorry guys, it's just Friday. The combination of a student ID and unit of study code. Unit of study code must be unique, right? Must be distinct. I showed you the tuple that we had. We had the same student enrolling in the same like unit of study. We don't want to take it as two separate tuples. So we just do it here. And now we just, it has to be from, just miss that, from transcript. You can name it a separate table. This is your new table that you are sure that every tuple that you have for a student and unit of study code would be unique. You don't have two tuples with the same student ID and unit of study code because you just use this thing. Now, what you have to do here is again group by. Group by what? Student ID and name. Whatever you have in your select student ID, comma name, and then having count. You can simply put count a star because you know that whatever you get here is just unique. You don't have to worry about that. Count a star is equal to 1, then order by at the end. Or oops, student ID. Right? So you understand, because I wanted to get the unique codes for each student. If the same student has enrolled in the same unit of study in different years or different semester, I don't want to count them as two separate units. So I just created that one using this. I use distinct tuples of the student and student ID and unit of study code from my transcript table. Then I just group them by, and I just get the result that I was after. Join. Select distinct student ID. Yeah. What's into the stick code from transcript? Why here? There we go. Why? Student. Look at this. Student ID. Name. Run it. A student. I'm getting blind. transcript. Did I misspell anything? Student ID doesn't matter, but student ID and name from a student, natural joint, distinct student ID, unit of study code, doesn't matter, but just in case. And then from transcript, the name of the table, did I spell it right? Transcript. Then you have to group by student ID and name, having count star is equal to 1, ordered by student ID. Why? Be nice to me. Just run it. Okay, must have an alias. Sure. Right. Because it says when you just include a select here as a second table, you have to pick an alias for that. So I just did that. And now if I run it, it doesn't complain anymore, hopefully. Yeah. So the problem is, problem was I didn't pick up a kind of alias here. You understand that for the second table, I just use another select query to create that unique tuple of student and unit of study code. I have to use an alias. Otherwise, I will get an error. Everything makes sense, guys? For those who haven't done so far, please use the QR code on the screen to register your attendance. Feel free to ask your questions if you have any. Otherwise, you're good to go, and I will see you next week. Questions? I put the link in the chat for those who haven't registered. No worries. Take care, guys. Enjoy your weekend. You're good to go if you don't have any questions. Thank you. Thank you. Take care. Bye-bye.
I just want to ask that can I have this sample question for this tutorial? Maybe I will try this question one by one after the tutorial. Maybe I want to check
what you're after, the questions are there. It's on Canvas. You don't need to ask me, and the solution will be released.
Oh, okay.
The solution will be released after we finish all the workshops tonight, maybe tomorrow.
Before tutorial, I just don't see that as any sample solution. Okay.
Because we haven't released it. We just wait until all the workshops are done. Then maybe early tomorrow, maybe tonight, you will see the solution.
Okay.
Released.
I will do that I will try this question by my own after the class.
Sure.
Okay. Thank you.
Do you have any question by any chance? You good?
Good. Have a good weekend.
Thank you. You too. Bye-bye.
Bye.